The photography project is an assignment in which we complete over a 4-month time period. During the extent of this project, we will be using 35mm cameras to take our pictures, and we will be developing our film. In doing so, we will be able to learn the chemistry behind film development and the chemistry of how photos are taken. We will also have an additional 11 sections needed to be completed by the end of the year. In addition to this, we will be researching the chemical composition of every item in our pictures. This project challenges us to have excellent time management, develop our researching abilities, and to increase our creativity in the format we have drawn from a hat. Welcome to another episode of Artifact. Today we are looking at camera obscura, or pinhole camera. In this type of photography, it happened in ancient times, and light used to go through this small hole, and due to the rectangular propagation of light, it would produce the image opposite or upside down. This was also known as the first point of photography ever in existence. I am JohnS, and I will darken the silver with heat. Why is it not working? And now we shall use direct sunlight. Aha! The silvers, they have darkened. But why does it not last forever? By using silver nitrate, I was able to create the picture, but I only get the dark outline of it. By using nitric acid, I was able to recreate my picture. But why does my picture never stay? I have already added a bitumen of Judea, and I have added my lavender oil. But I need direct sunlight. I'm not doing that. It worked! I will continue your legacy, Joseph. I have completed it. I shall call it daguerreotype. A little bit of sodium chloride. A little bit of silver nitrate. I've done it. This paper is now more light sensitive than the rest. I'm gonna fix these negatives with sodium hyposulfide. Later we should call it sodium thiosulfate. Now I'm gonna wax the paper before printing to reduce the grain of this paper. I should suggest the name photograph to tablet. I've made this process 20 times faster. I'm gonna use it by using wood glass plates. They are negative though. I'm gonna call this process collodion, and it is a solution of nitrocellulose in alcohol and ether. When they evaporated, a plastic-like film is formed. These chemicals are impervious to water, and they expose silver halides and remove the unexposed salts that could not penetrate the coating. The issue with this process is that a photographer had to sensitize the plate immediately before exposure, and had to do it while it was completely moist, which means I can't do anything but just sit here and wait. I have discovered a way to change the color of the ribbon. I have suspended the silver bromide in this gelatin emulsion. By doing this, I made it 60 times more sensitive than the old plates. And in this method, I have successfully replaced tripods, and we can enter the era of portable cameras. The year is 1833. I produced the first Kodak camera. This camera has a glass plate that contains a roll of flexible negative material capable of taking 100 pictures. Now once you press, you take it to the factory and they will process it for you. I see it. Using cathode rays, I have discovered the first X-ray. The year is 1924, and we have created the world's first 35mm camera. Now created a camera capable of taking pictures of moving things at high speeds. Got it. Introducing the Polaroid. The 35mm camera works by using its several components. The plastic and metal case makes up the exterior. The case protects everything inside the camera, and it is completely light-tight to protect the film from exposure to the light. The aperture, or the diaphragm, is a small hole that opens up for the time period in which you take the picture. It allows light to go through the camera and to reach the film. The shutter mechanism is a set of blades activated by a spring. They open up to let light in through the aperture for a precise amount of time before closing up again. The lenses scale down the larger images of the area of vision so it fits into the smaller area. Next, they allow the camera to be used in darker areas and to make the image form on the film quicker by concentrating the incoming light energy. They bring light rays into short focus on the surface of the film so images aren't blurry. They minimize distance between the aperture and the film. Adjusting the lenses actually brings the film closer to or further from the object, thus making different parts of the film show up on the camera. The film is a thin, flexible strip of plastic or other material coated with light-sensitive emulsion for exposure in a camera, used to produce photographs or motion pictures. It is taken out of the camera when it's time to develop the pictures. The chemicals involved in film development process are silver bromide. Potassium iodide, potassium bromide, and distilled water makes up the gelatin. Silver halide salts, chemical combinations of silver, iodide, and bromide, form crystals. The image gets on the film when the light strikes the film, but when it hits the inside of the camera, an inverted picture of its original is there. The light is then captured on the film and stored in negatives. Negatives are when the lightest areas of the photograph appear darkest and the darkest areas appear lightest. The first step in developing pictures is exposure. Exposure is when you take the picture. Exposure is referred to as the time period in which light enters the camera and goes onto the film. This unit of time is measured in lux seconds, and different amounts have different effects on the photograph. Too much light ruins the photo, and too little leads to a loss in shadow detail. The second step in developing pictures is development. The developer is a chemical that treats the emulsion in such a way that makes the latent image on the film visible. The longer a developer is in, the more the silver halides are reduced to silver, causing a darker image. Fixation stabilizes the image by removing the unexposed silver halide remaining on the photograph, leaving behind the reduced metallic silver that forms the image. With this step, it makes it insensitive to light. Without this step, the photograph would be affected by the light and darken. In this process, sodium and ammonium thiosulfates are used. The purpose of the stock bath is to stop the development of the film, plate, or paper by either washing off the developing chemical or neutralizing it. They use acetic acid when they want an immediate stop. It is done in a dark room and provides more precise control of the development time, as well as speeds it up. A stop bath that changes colors to indicate when the stop bath is exhausted and no longer effective is called an indicator bath. It has a pH indicator like bromoceryl purple and is used to determine when the solution has become too alkaline to use. The washing process is when they wash the film. This works because they remove all processing chemicals from the film emulsion. Due to the variables such as correct wash water rate and temperature, it influences the long-term dye stability, colors, for that photograph. Lastly, drying is when the film is heated to remove any water. Overview. The idea behind this lab is that we wanted to recreate the development of photographs as well as discovering the chemistry behind the process. Procedure. The film is loaded in the processing tank and done in complete darkness. The film is then opened, and the cassette is cut off the spool and leader, and the film is loaded onto the processing reel, all by touch. Then, we pre-soaked with water for 1 minute. For the third step, the Kodak D76 stock developer solution is used, 600 milliliters about, for 9.5 minutes. We had different increments of agitation, 30 seconds, and rest for 5, and then we dumped it. Then the Kodak stock bath is used for 2 minutes. They are followed by 5 seconds of agitation with 30 seconds of rest. Then we filled with water for 2 wash and dumps. After that, we used the fixer for 7 minutes, 30 seconds of agitation followed by 5 seconds of rest, and we did not pour it down the sink. After that, we fill and dump with water 10 times. Permawash is then used for 1 minute. We agitate it by inversion for the entire time. We then fill and dump 30 times with water. Next, we clean the tank with photo flow for 30 seconds. After that, we took the film out, we washed everything out, and we dried the film for 1 hour. We also had ice baths and heat baths to keep the chemicals at a certain temperature. Observation. We had some surprising results. Our pictures came out pretty good for the images were visible on most of them, except for the first film, which was completely black. On the light box, the pictures were visible, and Miss Smith pointed out that our problem was the lack of consistency in agitation, for Dave and I were delayed in handling the agitator chemicals and missed a time increment at one point. Our photos looked as following. Conclusion. We learned a lot from this lab. We learned how to make the film permanently through agitation and witnessed over and under development. We all played our part, but we rushed and slipped up a bit. First off, the images were overdeveloped, for there were splotches of black on our photos. This was because we did not have enough developer for both reels, and because our agitator had agitated a little bit too fast, and uneven times of agitation, either too fast or too slow. The slightest slip-up showed in our final product. For example, in one group, they had shaken fast and had not allowed any reaction to take place. We also had a few communication errors because we were friends and expected better of not only ourselves, but of our group members as well. It's also fair to note that we did dump one of the chemicals down the sink when we weren't supposed to. All in all, this lab helped me firsthand experience how photos are created. The developer. The developer is a Kodak Professional D76. The developer is a base, which means it has a pH of over 7. The chemicals that make up the developer are hydroquinone, bis-4-hydroxy, and methylanium sulfate, water, the chemical formula of H2O, metal, with the chemical formula of C7H10NO2SO4, sodium carbonate, with the chemical formula of Na2CO3, sodium sulfite with the chemical formula of Na2SO3, and granular borax with a chemical formula of Na2B4O5 OH4 8H2O. The stop bath is an acid. This means that the stop bath is a pH of less than 7 because its purpose is to stop the reaction. The stop bath is a Kodak Professional indicator stop bath. It is made up of an acetic acid with the chemical formula of CH3COOH. The fixer has 2 solutions, and it is called the fixer Kodak Professional. The solution A contains ammonium sulfite with the chemical formula NH4-2SO3, sodium bisulfite with the chemical formula of NaHSO3, ammonium thiosulfate, sodium acetate with the chemical formula of C2H3NaO2, and water with the chemical formula of H2O. Solution B contains sulfuric acid with the chemical formula of H2SO4, aluminum sulfite, which is Al2SO43, and water, which is H2O. The permawash is called HyCO HG85. It is made up of ammonium sulfite, NH4, 2SO3, and sodium sulfite, Na2SO3. The PhotoFlow, also known as Kodak Professional PhotoFlow, is a polymer, and it contains p-teryloctyl phenoxypolyethoxyethyl alcohol and propylene glycol used as a preservative with the chemical formula of CH88O2 and water with the chemical formula of H2O. I love my glossary live stream. I'm gonna follow along with my very own dictionary. Rectilinear propagation is the transmission of light in a particular direction or through a medium, consisting or moving in straight lines. A silhouette is the dark shape and outline of someone or something visible against a lighter background, especially in dim light. Lithography, studied by Joseph Niepce, it is the study of printing/writing using water and oils on a stone. Bitumen of Judea, an asphalt that was used by Joseph Niepce. It is a light-sensitive material and was used to complete one of the first photographic processes. Daguerreotype, created by Louis Daguerre. The daguerreotype was a photograph taken by an early photographic process consisting of an iodine-sensitized silvered plate and mercury vapor. The image would end up on a silvered plate, while the image was made visible when the mercury vapor fuming with light. Collodion, using wet glass plates that were negatives. This photographic process was 20 times faster than all the previous methods. Created by Frederick Scott Archer. Nitrocellulose, also known as gun cotton. This substance was used by Frederick Scott Archer in his collodion process. Gelatin emulsion, coated onto a substance of glass, films to make photographic images stay. Cathode rays are beams of electrons emitted from the cathode of a high vacuum tube, used by Wilhelm in the first ever X-ray. Negatives were when the lightest areas of the photographed subject appear darkest and the darkest areas appear the lightest. Exposure, step in photographic development, which is referred to as the time period in which light enters the camera and goes onto the film. Developer, step in photographic development when chemicals treat the emulsion in such a way that makes the latent images on the film visible. Fixation. Step in photographic development which stabilizes the image by removing the unexposed silver halide remaining on the photograph, leaving behind the reduced metallic silver that forms the image. Stock bath is a step in photographic development when the development of the film, plate, or paper is stopped by either washing off the development chemical or neutralizing it.